Welcome to another edition of Data Center Pulse. Today I'm talking about the eBay Modular Data Center RFP that was published on July 5th. We put this out through datacenterpulse.org, and that was primarily for us to reach the industry, to share what we're trying to accomplish, actually to put our problem out there as well, and then have the industry come back and answer it. Now, a lot of people are asking, why would you do that and be public about it? We didn't want to go back and limit the amount of people that could participate in the RFP. So we said, let's open it up and see who's out there, because there's so many companies and so many innovators out there that could come back with an answer to our problem. Let's make sure that they can see it and have an opportunity for it. Now, what are we trying to accomplish in the RFP? Very simply, the RFP is a 8,000 square foot data center in Phoenix, Arizona with 4 megawatts of IT load. And we're trying to figure out the most flexible and modular solution that we can put in there to be able to scale the business up as we need it. Day one, it'll be 2 megawatts of IT capacity, but we want to scale it higher than that. Now, the idea was to accelerate innovation through these companies. We give you the problem. We don't put boundaries around what you need to do. We say, here's the box, here's the IT load, here are the temperatures. Now tell us how you build the most flexible, efficient, innovative solution that handles today's technology as well as tomorrow's. First, the data center itself. So it's 3 stories, and if you look at it, the ground floor is open. It's 8,000 square feet, and we've got a 3-foot raised floor area, but what it's used for, we don't really care. The bottom floor is really for any kind of rack or smaller type units that are going to go inside of a data center. How that data center is laid out, what you use to make it work, don't care. What I care about is I'm going to achieve the max amount of IT load and flexibility. I'll talk about that in a little bit. The second floor is for people space and for storage space. Second floor is built. The building is already going up, and you'll see in these pictures here that we've got the footings going in and the construction's happening. The building will be built by the end of this year, and we will start construction on the data center January 1st. Now, the roof is already set up to be able to do 12 fully loaded 40-foot containers. Now, I say that because that's the 8,000 square feet. The building is fortified to be able to handle all that density, that weight itself, but how you put it together, we don't really care. What we're looking for is we want to be able to land IT and physical infrastructure capacity, mechanical, electrical, plumbing capacity on the roof or adjacent to the building to be able to handle the max amount of IT load. We'll be able to get more power. Right now, my design engineer basically went through, Mike Lewis, and we said, what's the maximum amount of IT we believe we can get in this physical footprint? Because we're bound by the property itself. And we thought, well, 4 megawatts we think we can get. It's pretty dense. That should work. But for everybody doing the design, if you can do more, do more. How would we enable us to do the maximum amount of IT load within this footprint for this investment? So we're starting with 2 megawatts worth of capacity, but we want to be able to scale. Now, what scale would we do it in? Again, what's the best solution that you would propose to us? Is it in 200 kilowatt chunks, 500, a megawatt? What is it? You come back with that answer. Okay, so those are the parameters. It's a physical building. Just think of it as a box. How would you optimize for that box? In these 2 layers. We'll have pipework to be able to get to chilled water. It will be a chilled water-based system, but we want to be able to do high temp air and high temp liquid at the same time. All right, now, I'm going to tell you about another concept here. And this is the future. This is pretty simple. How would you go build this infrastructure? Now this is what's a little more difficult. It makes this such an interesting RFP. We want to be able to do today's solutions. So today's temperature water, as well as inlet air temperature. So we roll those things into the ground floor. But we also want to be able to enable high temp liquid and high temp air solutions. My goal is that ultimately I'll be able to do, I'm tuning for 2 parameters. The first parameter is the CPU temperature. The other one is outside air. How do I now say those 2 dictate everything else that happens around it? So the maximum temperature I can run these CPU systems at, I want 100% free cooling in Arizona year-round. What we found is 85 degrees Fahrenheit for the water is the maximum wet bulb temperature we have to actually cool for in Arizona, even if it's 130 degrees outside. The key being, that will be the inlet temperature for the ultimate end state products. Consider you've got a rack. Inside of that rack, I've got a CPU. I've got some cooling mechanism cooling that CPU. Now what I want is a tower. That loop will exchange to that rack. I don't care what this rack is, how big it is, whether it's a container, a pallet, whatever, it doesn't matter. But the inlet water temperature would be 85 degrees Fahrenheit, minimum. So that I can now have 100 degrees Fahrenheit in the loop to 122 degrees Fahrenheit. Again, 50C is just a number I came up with. What is the optimum temperature for that CPU? The main point is I can run this hotter as long as I've got closely coupled cooling, meaning that I'll have liquid cooling to that chip. This is kind of an end state, so that we can now optimize the performance of the system. But the two parameters, again, I'm looking for, how do I get the optimized the optimized temperature for the CPU, and then the optimized outside air temperature for free cooling. Everything else can design around that. So, 85 degree inlet, again, return whatever you think that would be. I'm just guessing it's a 10 degree rise. If it's 105 and a 20 degree rise, 30 degree rise, that's fine. Whatever you want to do for that efficiency. But the key is, how do I ensure I get that temperature coming in? This is next generation liquid cooling equipment that we're looking to be able to plug in here. Whether it's going to be a 40-foot container fully loaded on the top, or a pallet or a rack that rolls into here, I need the capability to be able to plug that in. Now here's the big challenge. How do I do today's technology if this is running at 58 degrees Fahrenheit? You guys need to come back with an answer that's going to say I can roll in today's technology and tomorrow's. So, water coming to the site, you'll have that. How would I design the infrastructure to be able to give me varying water temperatures to those devices? The other one is, remember, I will have high temp air solutions as well. How do I build the next gen solution so that I can roll multiple devices in at any given time? Because I don't know what the technology is going to be. I don't know what performance we're going to get, but we're going to keep pushing those boundaries. But this is a generic solution that I don't really care what's inside the rack or the container or the box, as long as it's going to give me the maximum compute performance to the optimum cooling infrastructure performance. It's not either or, and it's not designing everything to make the facilities look absolutely great without considering the workload itself. It's marrying these two together. So hopefully this gives you a little more clarity on what we're trying to accomplish. But what I want you to think about is you should be able to come up with a design that makes each rack or each container or each module independent. So a solution that can scale to be able to do multiple water temps, high temp air solutions, most likely in here or just going through containers or boxes on the roof, that can go for that 85 degree Fahrenheit in Phoenix, Arizona. Because the key for me is the industry is seeing what's going on, real project, and we're all learning at the same time. Again, I'm blessed to be able to be public with this information. A lot of my peers in the industry are not. So I want to be able to share this. But I'll tell you, there's a lot of people watching what's going on right now. Because ultimately, this will drive the type of products that we're able to buy. It'll build the business case so that we can go to our management and say, I think we should buy this next generation solution. It may be liquid cooled servers to be able to do twice the performance at half the OpEx. Don't know yet. But the key is a flexible environment that gives me maximum efficiency for all these different types of products that are coming back in. Now, I believe modularity is the key because I couldn't build a fixed infrastructure that could do this. But I could build a modular one that allows me to grow electrical, mechanical, and others, mixed temperatures, etc., and snap them in as I need them. So thanks for watching. Again, if you have more questions, please email modular@datacenterpulse.org, and we'll get back to you as soon as we can. And watch for more updates on Data Center Pulse.